Okay, solenoid, we have a core, which might be air, but it might be iron, which is typical, okay? Something that enhances a magnetic field. We've seen how that works in lab. You take a coil without having a bolt through it and measure its magnetic field, and then you put a bolt through it and measure its magnetic field. It's much higher, tens of times higher, when you got the bolt in there. If you haven't done that, well, you have an opportunity in our next lab, which we need to talk about. And you can do that in 5 minutes, okay? So anyhow, here's your solenoid, and what we do is we wrap this solenoid tightly so the solenoid is wrapped with lots and lots of coils, okay? Now, if you look at the top of the solenoid, and I'm not going to draw them quite as small as I did, but here are a cross section. Here's a cross section of your wires, right? And let's say it's coming out of the board here. Okay? Now there's also wires down here. Okay? And it should all be filled in. I'm not going to take the time to do that. Okay? Now, if I let my curve be this, and if we assume that this solenoid keeps going, okay, so this is just a small part of the solenoid, okay, this curve is being penetrated by currents, right? Okay, so if this segment has length L, and there are N loops per unit of length, then how many loops or how many of these cross sections are there in length L? Well, if it's N loops per unit of length, you don't have to think too hard to see. You're going to multiply that by the length to find out the number of loops, right? So the current penetrating the inside of the loop, of the curve, is I times N times L. Okay? So, the integral of the magnetic field around the loop, the curve, there's a curve, is what? I times N times L. Okay? That times your constant. It's proportional. Haven't wanted to confuse things with the constant. Okay? We want to figure out what the constant has to be. Turns out that's actually fairly simple. Okay? Make sense? So, this is called Gauss's law for magnetism. Okay, it's much like Gauss's law for electric fields. Okay. It turns out that the way we've made this loop, and let's make the loop perfectly rectangular, and I'm using the word loop for the things that go around the core and also for this. So I'm going to try to call this the curve, the bounding curve. Okay? By symmetry, what's the direction of the magnetic field inside? Go back to Biosavart and see if symmetry helps you.
Either